Hello and thank you for watching the next video on equations of lines in standard form. In this video, I plan to go over and give you examples on how to write an equation that is standard form into the slope-intercept form. The purpose of this is to identify the slope of the line. Many times we're interested in identifying the slope of a line, but we don't have it in the slope-intercept form. So I'm going to go over some examples on how to write the equation in standard form into this slope-intercept form. So first, let's discuss again why it's important to know how to write things in the slope-intercept form. Well, one is because if we want to identify when lines are parallel and perpendicular, well, we need to know what the slope of the lines are. Because lines that are parallel have the exact or equal slopes. But if lines are going to be perpendicular lines have slopes that are opposite, reciprocals of each other. So we cannot identify again if these lines are going to be parallel or perpendicular unless, of course, we have the equation of our line written in the slope-intercept form. So the slope-intercept form of the line, recall, is the format of y is equal to mx plus b, where the variables which correspond to the slope is the letter m. I know many times we discuss as teachers and say that the slope is the number in front of the x. And well, when it's written in this format, it's correct. The slope is equal to that number right there, the number that's being multiplied with the x. But it again only works if it's written in that format. So we have to be able to recognize when we have the slope-intercept form. And it's easy to recognize because we're solving the equation for y. So like on this example, y is equal to mx plus b. So our slope would be the number -1/3. Again, as indicated in this example right here. So let's look at some examples. Well, first let's go over what the standard form of a line is. The standard form of a line is this format: ax plus by is equal to c, where the a term, the x term, and the y term are being added together. Now again, added means again it's equivalency of saying that you're adding a positive and a negative number, okay? And I know many times when we add a positive and negative number, we write the word minus. So for an example, let me give you some examples of things written in standard form. Here we have 9x plus 3y is equal to 7. So this example here is written in standard form. Notice again the format of 9x, the 3y, and the constant, again, the c is the number 7. Now it could also be written backwards. We could have the y term in the front. Sometimes people will do that, or sometimes it will be written like this again. But this is technically not the standard form, but again, it's an example of it not being in the y-intercept form. And the key thing that we need to know and understand about this is that when it's written in this format, this number in front of our x, this letter A, capitalized A, does not represent the slope. This is not the slope. So in order to identify the slope, we have to rewrite it. So let's go over the steps on how to rewrite this. So step number one is that we have to move our x term, and again, move is relative here, our x term to the opposite side, which in this case is going to be to the right side of the equation. Well, so to do that, since we're adding here, we're going to simply subtract it, but it's going to look like that. So a positive over here would mean it's negative on the other side. So we end up with y is equal to -1x plus 6, which is our second step. Our second step is to simply bring everything down. Okay, or simply bed for shorts. Bring everything down. Meaning again that nothing gets combined. All right, these two terms do not get combined, and it's not going to equal to 5x or 7x or anything like that. The y is not going to be combined with anything, so we're going to end up with simply 1y right there. And on the right side, we're going to end up with the -1x and the 6. I'm not going to add these together, combine it, or do anything like that. And our last step, which in this case is a little redundant and not necessary, is to divide by the coefficient of our y term, our y variable. And like I said, this is redundant in this example because we're going to divide by 1. Our coefficient here is going to be the number 1. So if I divide everything by 1, so if I divide these two numbers by 1, and obviously this number also gets divided by 1, we end up with y is equal to -1 divided by 1 is going to stay the same as -1 with an x, and +6 divided by 1 is going to stay as +6. So in this example, it was not necessary to essentially do the last step, but just for practical purpose, for uniformity purposes, I'm going to follow the exact same 3 steps every single time. Now, some of these steps, sometimes the first step isn't required because the x is already on the right side, but we have a number in front of the y. So, and the first and second step are already pretty much done, and the only thing that's pending is to divide by the coefficient of that variable. And I'll give you an example of that in a bit, okay? So let's move on to this example right here. So on this example, again, we're going to follow again the exact same 3 steps. So we're going to start by first moving our x term to the opposite side, making it -5x. And I know it doesn't make sense that I should have these again lined up like this because they are not like terms. So normally I do not line these up, but I'm running out of space here. And I don't want to just simply move it. You know what? I will. Okay, so they're not like terms. Now you could put bring everything down. That would put the -2 first, and then the -5x in the back, but which is fine. But in slope intercept form, you usually have the x term first. So I'm going to write the -5x first, and then the -2 second. Now I can write this as plus -2. That's the same equivalency. So if you're more comfortable writing as plus -2, that's fine. But if you think you can handle just simply writing and understand why we have -2, because we're going to add a -2, and with the adding a -2 is the equivalency of simply subtracting 2, then that's great as well. Our last step is now to divide by 2. So we're going to divide by 2. So y is equal to -5 over 2x, and dividing a -2 by a +2 is equal to a -1. So that's a result. And like I said, sometimes the first and second step are already done for us. And let's say we have this equation. We have 3y is equal to -7x plus 6. So here you can clearly see that the x term is already on the opposite side, so that covers step number 1. Everything is already brought down because again nothing is combined, so just like this, so step number 2 is done, and the only thing that is pending is to do step number 3, which is to divide by the coefficient of the y variable, which is in this case is going to be number 3. So y would equal to -7 over 3x plus 2. So sometimes the first 2 steps are not necessary, and we just simply have to go straight and jump into the last step, which, because again we want the coefficient of the y to be a 1, and since in this example up here it was a 3, I would do the last step and divide everything by the 3, by that number, by the coefficient of the y. Let's see, let's do some more examples. So here again the exact same thing. We would start by subtracting the 2x to the right side, so I would write -2x. I end up with -4y is equal to -2x plus 28, and then we would divide everything by the coefficient of the y, which is again -4. So we divide everything by -4. So y is going to equal to +1/2 x, and 28 divided by -4 is equal to -7. And again, like I stated earlier, you can write this as plus -7. That's the equivalency of simply subtracting a 7. So whichever way you write it, again, it's still going to be correct. But this is the normal way that we represent that idea, that we're adding a negative number is by simply saying that we're subtracting that positive value. So we're subtracting 7. On our next example, again, we're going to move that to this side. And this is now a negative 1y is equal to negative 3x plus 5. So I brought everything down. And this time it is not redundant. It is actually quite necessary to divide by a negative 1. Dividing by a positive 1 is not necessary, but dividing by a negative 1 is, because dividing by a negative 1 is simply going to switch the signs to these two numbers. Negative 3 divided by negative 1 is equal to 3, and 5 divided by negative 1 is equal to negative 5. So moving quite along, again, here's another example. We're going to again subtract the 6x. So move it to the right side. So we end up with negative 6x, also negative 16. We're going to divide by 8. And y is equal to negative, well, this simplifies to 3 over 4x minus 2. And again, the purpose that we want to do this is because we want to identify specifically, let me start with the first example. We want to identify the slope of our lines, okay? That's what we really want to focus on, identifying the slope of each one of these lines. Like right here, the slope of our line is negative 1, and I didn't do this on the previous example, so let me go back. On the second one, now that we have it in slope-intercept form, the slope of our line is negative 5 over 2. And again, we're focusing on the slope-intercept because there's an easier way of identifying the y-intercept. If I'm interested in identifying the y-intercept, then I would just simply divide this number by that number. But again, I'm getting off track here, and let's focus on what the slope of our line is. Because like I said at the beginning of the video, the purpose of this, of knowing how to identify the slope when it's written in this format, is because more times than not, we'll be interested in identifying if we have two lines, we're going to compare two lines, we need to know what the slopes are. So here, we do not know what the slope is until we write it in this format, and I know that the slope is negative 5 over 2. Notice that the slope is 1/2 over here, so m is equal to 1/2. Here, m is equal to 3, and number 5, m is equal to negative 3 over 4. Now, if you look at something that's going on here, but this again only works if we have this thing written in standard form, notice that this number right here actually happens to be the ratio of getting the number in front of the opposite number of the x, which in this case is a negative 1, and dividing it by the value of the coefficient of the y. So dividing these two coefficients, 1 divided by 1 is equal to 1, and we just simply get the opposite of that number, which makes it negative. Look at over here. If I divide 5 by 2, that's equal to 5 over 2. That's that number right there. And we just simply make it the opposite. Notice that a positive 5 divided by positive 2 is positive 5 over 2. But then simply making it the opposite gives us the slope. It matches to the slope of that line. Look at on this example. Getting 2 and dividing it by negative 4. Negative 4 is equal to negative 1/2. 2 divided by negative 4 is equal to negative 1/2. Notice that the 1/2 matches exactly that number, but instead of getting a negative value, we ended up simply with the opposite of that. So notice that the slope matches the opposite of dividing those two numbers together. The same thing on number 4. Notice how if I divide these two numbers, positive 3 divided by negative 1 is equal to negative 3. Notice how this number is the opposite of that number. So if I divide these two numbers, I can figure out the slope by dividing these two numbers and simply getting the opposite of that answer. And the same thing right here. If I divide these two numbers, 6 divided by 8 gives me the fraction of 3 over 4. Notice how 3 over 4 is simply the opposite of our slope right there. So there's a little shortcut there. If you pick up on a pattern, that you can identify what the slope of the line is when we have our standard form by using that pattern right there in that shortcut. But again, it only works if it's written in this format right there. It does not work if we have our equation already in this format. I would actually have to divide the number out and written in slope-intercept form. But if it's going to require us to do all three steps that I've been mentioning, again, moving the x, bringing everything down, and dividing, having to start from the very beginning, I can use a shortcut to figure out what the slope of the line is by dividing these two numbers and then simply get the opposite of that answer. So look, in example number 6, if I divide these two numbers here, if I divide the 1, the coefficient of the x, and I divide it by the -4, the coefficient of the y, 1 divided by -4 is equal to -1/4. So the slope of this line you're going to see is going to become the opposite of this number. So if this number is -1/4, I should end up that the slope of this line here would be +1/4, simply the opposite of that. So let's see. So let's work it out again doing the exact same 3 steps. So if I move the x to the other side, that's going to be -1x. I have -4y is equal to -1x plus 0. And that again, adding the plus 0 is a little redundant, but I'm going to keep it there just to keep it consistent and uniform to what I've been doing on the other examples. Now dividing by -4, we get that y is going to be by itself, which is what we want. Negative divided by negative is positive. So we end up with +1/4x plus again 0. And adding 0 again is redundant, so I'm not going to write that. It's not necessary to say that we're going to add 0. So I'm going to leave the equation in that format. And look, our slope of our line. The slope of our line is equal to 1/4, which again, like I told you, is simply the opposite of doing what I did earlier, getting the 1 and dividing it by -4. So by doing that, if I get the opposite of that, that is always going to match to the slope of our line. Now, the purpose of this, again, the purpose of being able to identify the slope is because on some examples, we're asked to identify if two lines are parallel or perpendicular, but they're not obviously always going to give us our line in this slope-intercept form where we can identify what the slope of the line is. Like in this example here, notice that both of these two equations are not written in slope-intercept form. So I can identify the slope of the line again by rewriting this and writing it in the slope-intercept form. So I can do that with the first one. So let me do that. So we have 2x minus 3y is equal to 6. So I move the x to the opposite side of my equation. I end up with -2x. So -3y is equal to -2x plus 6. I divide by -3 since I'm multiplying. And the reason we divide again is because we're multiplying the y with 3. So we're going to divide by -3. And our value of y is going to equal to 2 over 3x minus 2. So you see our slope is equal to 2/3. So our slope right here is equal to 2/3. Now in order for the line to be parallel, the slope of this new line right here would have to be the exact same number. But in order for the two lines to be perpendicular, the slope here of this second line would have to be the opposite, and the number would have to be flipped. So I would have to get that. So I need either this number or this number to be parallel or perpendicular. If it's neither of these two things, then the two lines are neither parallel or perpendicular to each other. So on the second equation, I'll need to identify the slope. I'm going to use a shortcut for that one. So if I get the, oh, this is not written in the right format, so I'm not going to use a shortcut. I'm simply going to move the x term to the opposite side. So let me just right over here, we have 2y minus 3x is equal to -12. So I'm going to move the x term to the opposite side, which is going to make it positive 3x. And bringing everything down, we get positive 2y is equal to positive 3x minus 12. We're going to divide by 2, and the value of y is going to be positive 3 over 2x minus 6. And again, we're only interested in the y-intercept. So in that number there, which is equal to 3 over 2. So it was close. They're not the same numbers, so parallel is definitely out. This is definitely out. But they're not perpendicular either, because even though they are numbers are flipped, again, there's two conditions to be perpendicular, is that they have to be opposite signs. So since this one is positive and this one is also positive, it is not going to be perpendicular. So here it is neither. They are neither parallel nor perpendicular to each other. Let's move on to our next example. Let's see, in this example, which of the following lines is perpendicular to this one? So we want to create the equation of a line again. Y is equal to mx plus b. But we need to identify the slope of our new line and use this point, this x and y value, to figure out the value of b. Well, they're not giving us the slope because the equation is written in standard form. So 2x plus 3y is equal to 6. So I need to get the slope of the line from here. Now I have two options. I can use this shortcut, which is dividing these two numbers and getting the opposite of that answer. So if I get 2 and divide it by 3, I'm going to end up with 2 over 3. It doesn't simplify, but to a decimal. Well, the opposite of 2 over 3 is negative 2 over 3. So this is the slope that I'm going to use for that new equation right there. Now, let me actually do it now using again the procedure I showed you in the first slide by again following the same 3 steps. I'm going to move the x over, making it negative 2x. 3 over y is going to become negative 2x plus 6. I divide by 3. And y is equal to negative 2 over 3x plus 2. So you see, look, now that I have the slope, this is the slope of our line. Again, this is the same number I told you I was going to get from this equation there. Now, since I want this new line to be perpendicular to this line right there, well, in order to be perpendicular, I need these two slopes to be opposite reciprocal. So I need this slope right here to be the opposite reciprocal of whatever this number is, which is going to be positive 3 over 2. So this is the number I'm going to use for m. I'm going to use this number for the value of m. The only thing I'm missing now is the value of b. Well, to get the value of b, using this formula, I'm going to plug in the x and the y value. So I'm going to write b plus mx is equal to y. I'm just simply writing again this formula in the opposite order. And if you saw the previous video to this one right here, you would see again that I've done this one, this type of situation before. I'm just simply writing this formula backwards and plugging in again the numbers that I have. I have the value of m, which is 3 over 2. I have the x value, which is 4, and it's going to equal to the y value of 1. And again, the purpose, and just to explain it in case you didn't watch the previous videos, because I like, again, for some reason my students, again, find it easier to solve the equation in this format, because again, my variable is on the right side of the equation, than it being on the left side of the equation, rather than being it on the right side of the equation and doing things kind of like backwards to the way we usually solve equations. So here, this would require us to multiply these two numbers, which is going to equal to 6. And then subtracting the 6 from both sides, we get that the value of b is equal to negative 5. So this would be the equation of our new line. Let me move all of this out of the way real quick. Let me move this over. And the equation of our new line, y is equal to m. That's 3 over 2 x plus our y-intercept of negative 5. So you see again, if we need to write the equation of a line or identify if two lines are parallel and perpendicular to each other, we would need to rewrite these equations into the slope-intercept form to identify the slopes and thus compare if two lines are parallel or perpendicular to each other. Or if I need to write the equation of a new line perpendicular or even parallel to an existing line, I would have to rewrite this into slope-intercept form so I can identify the slope of the line. So again, that's what the whole objective of this video and these examples are, is to know how to rewrite the equation from this standard form to the slope-intercept form to identify the slope, and then apply it to either come up with the equation of a line or to compare the two slopes and identify if the lines are parallel or perpendicular. Let's do one last example. Similar to example number 2, here we want to come up with the equation of a line, but this time that is going to be parallel to this line right there, and that passes through that point. Well, I would have to first start by identifying what the slope of this line is, because in order to be parallel, the slope of my new line, y is equal to mx plus b, is going to have the exact same identical slope as this line here. So since this equation is written in standard form, I would have to rewrite it in slope-intercept form, moving the 2x to the right side, bringing everything down, and dividing by 5. We get that in slope-intercept form, the equation of the line is y is equal to negative 2 over 5x plus 6 over 5. And since this new equation needs to be parallel to this equation there, and the slope of this line is equal to negative 2 over 5, then the slope of this new line over here is also going to be negative 2 over 5. So that's the number I'm going to plug in for the letter M. Now to figure out the y-intercept, using again this formula or this form, y equals to mx plus b, I'm going to write it backwards. B plus mx is equal to y. I'm going to plug in the slope, which is that blue number. There should be plus, sorry. Negative 2 over 5 times our x value, which is 5. That's that number right there. And it's going to equal to the y value, which is 3. So I'm going to replace that with 3. Multiplying negative 2/5 with 5, that's going to equal to negative 2. And adding 2 to both sides, we get that the value of b is going to equal to 3. And again, I really don't worry about adding it on this side because I know that's going to equal to 0. The negative 2 and the positive 2 is going to equal to 0. I'm really more focused on what happens in it on the other side. So there, we end up with that the value of b is equal to 3. So substituting in all of this information, replacing the m value with negative 2 over 5, multiplying that with x, and then replacing the b value with 3, we get that the equation of the line that is going to be parallel to this line here and goes through that x and y value is equal to this equation there. So y is equal to negative 2 over 5x plus 3. And that concludes again the examples on how to write the equation of a line from standard form to the slope-intercept form, and the applications or the necessity of knowing how to do that, which is to be able to write the equation of a new line parallel or perpendicular to the existing given line, or if to identify two lines as parallel or perpendicular to each other, or like in this case, I found out that they were neither. They're neither parallel or perpendicular. They just simply intersect at some random angle. So that concludes, again, like I said, my examples here and their applications. Well, I hope this was helpful. And if, again, it was, and you like this video, do not remember, again, to subscribe to my YouTube channel and to get, again, notifications and updates of new videos uploaded. Well, thank you again for watching, and hope you have a great day.